What is the equivalent resistance for the circuit shown below? Now it's clearly a combination circuit with all kinds of series and parallel sections. If you like, once again, we'll imagine our batteries right here. Sometimes it makes it a little easier just so we can see what's going on. And we see the current comes out of the battery, goes through the 6 ohm resistor, and here's where it starts to split up. So we've got all kinds of parallel sections. The trick to these is to try and simplify what you know for sure and just keep working your way backwards. And once again, I always prefer to move as far away from the battery as possible if it makes sense. And in this case, I've got this 4 ohm and this 6 ohm resistor along this back little path at the end. And notice there's a direct path between the 6 ohm and the 4 ohm. So these two are said to be in series. So if I look at the back path, and I'll call that our series 1, that little series section, we can quickly convert that and find its equivalent resistance by adding them together. So I'll simply go R5 plus R6, which is 4 ohms plus 6 ohms. So that back little bit becomes 10 ohms. So now we can redraw our circuit once again and imagine what's going on as we go bit by bit. So there's my battery. Still got this first resistor. Still got this one down below. Still got this upper one. Still got this one along the diagonal, which we're going to deal with shortly. And now this back one, these R6 and R5 have become replaced with a 10 ohm resistor because they were in series. So I'm going to put one 10 ohm resistor in their place. So this back resistance here, we called that RS1, and that was 10 ohms. Now let's put in the values of the other one so we remember what's going on. This one was 6, this one was 8, this one was also 8, the diagonal, and this one was 4. Now again, as far away from the battery as possible. I've got this 10 ohm resistor, and on one side of the 10 ohm it's connected to the 4 and the 8, and on the other side of the 10 ohm it's connected to the same 8 as before, and in a different resistor, the other 8 ohm resistor. My point is that it's directly across the 8 ohm resistor. Either end of this 10 ohm is on either side of this 8 ohm resistor. So those two are said to be in parallel. The other way to imagine it is I could take this little point, let me put it in blue, this little junction point right where this diagonal 8 ohm resistor attaches down here. There's no reason why I couldn't slide this way and maintain a connection all the way along and end up with a circuit where this 8 ohm looks more familiar. So if I slid this 8 ohm all the way over to, say, this point, this end, and maybe slide this little end back a little ways to here, my circuit would look as follows. Now let's see if I can erase it without making too much of a mess here. So it would look like this. That 8 ohm resistor, when I slide it back, is right there. Now when I draw it that way, it becomes suddenly much more familiar. These two are in parallel. So let's figure out what they are when we do the parallel resistance formula. So 1 over R parallel will be 1 over 8 plus 1 over 10. And when I do my formula, I go 8 to the minus 1 plus 10 to the minus 1, and that's 1 over RP. Don't forget, I have to flip it one last time. So whatever I get when I go 8 to the minus 1 plus 10 to the minus 1, I have to flip that one more time. So 8 to the minus 1 plus 10 to the minus 1, that gives me 0.225. And when I hit x to the minus 1 one last time, I get 4.44. So those two parallel resistors gives me 4.44 ohms. So again, if I redraw the circuit, I would get a same 6 ohm resistor up here, that hasn't changed. Same 8 ohm resistor here. same 4 ohm resistor up here. I haven't touched that one yet. But now the back little bit has been collapsed down into one single resistor, those two resistors that were in parallel, of 4.44 ohms. And now you can see where this is all leading. Again, we see a series section here, the 4 and the 4.44. I can add those up and get an equivalent resistor there. 4 plus 4.44 becomes 8.44. So if I take my eraser and redraw this circuit one more time, those two become the equivalent of 8.44. And then again, we have another little parallel section. The 8.44 is in parallel with the 8. So if I just do this little section right here, 1 over R parallel is 1 over 8 plus 1 over 8.44. And if you're getting used to doing the parallel section, that becomes 8 to the minus 1 plus 8.44 to the minus 1. Which gives me 4.1. So all of this becomes 4.1 ohms. So again, if I grab my little eraser and I just wipe out all of this and replace it with a single 4.11 ohm resistor, I'm almost done. You can see now we just have a simple series circuit. The 6 is in series with the 4.1, and my overall equivalent resistance will be 6 plus 4.1, which is 10.1 ohms.